Hello, my name is Nancy. Today I'm going to present real-time analytics using Cloudera Impala in manufacturing use case. Asking why do we have to do the big data analytics? I think it's because we want to find a way to make money from that big data. In manufacturing also, we want to improve the supply chain management. We can do that by tracking the defective parts or finding the bottlenecks in the production line. The faster we can analyze the data, the faster we can detect the defective parts and also the bottlenecks in the production. From these reasons, we can save the money and time on the defect parts. Also, we can solve the problem immediately in order to get the highest output. Some problems that we have are the data is separately stored in many databases, and it takes much time to retrieve the completed production data. Also, the people in the factory are familiar to SQL query. That's why we need Cloudera Impala. In this project, I will show how to use Impala to find the bottlenecks in the factory. First, we need to install the Cloudera Manager. It is recommended. And the installation guide can be found on the Cloudera website. And I would like to focus on the real-time analytics, not Impala, so I will skip the installation part. After finish the installation, you get this screen and it will show all of the program on your cluster. And you can see that here there is a Hue, Hive, and Impala. And in my case, I also want the people in the factory be able to use their big data analytic tools. So I will use Hue Web UI to query Impala. So from the service menu, click on Hue and choose Hue Web UI and you will get this screen. In order to query, first we have to create a table. Since Impala use the same Hive meta store, so we will create the table in Hive using the command here. And after created the table KH sample, I will load the input data from local path into the KH sample table. After finishing the processes, we can check the sample of the table from Hue Web UI also. And you can see from the screen that the data I'm using is the simulation data, it's the production simulation data, which include the simulation date is 10-day simulation from December 13 to December 22nd. And in this data is also included the production ID, operation ID, also the machine ID, and also the input, output, and the work in process also. The total records of this input data is around 1 million records. Before we do the query in Impala, we need to refresh the Impala shell using the command refresh. If you don't do this, when you query on Hue Web UI, the error of table cannot be found will be shown. Next, we will go back to Hue Web UI, and we can query by click the Impala logo next to Hive logo and input the query into the query editor and then press execute and you will get the result in a second. Talking about query, as I said before that I am going to find the bottlenecks of the factory. And the bottlenecks of the factory is the bottlenecks machine. So we can calculate the bottlenecks by the easiest way is to focus on the increasing of width in each machine by day. The process of the query is we have to group the data by machine names and sum the value of width by day. And this data was simulated from December 13 to December 22nd, and I said, so I will sampling the date 14, 16, 18, 20, and 22nd for calculation, so that we have at least 5 subqueries in form statements. The sample of my query is here. As you can see, I select the machine name. a.resort.group is the machine name, and the width value of each sampling day, and the subquery is in the from statements. And also we have to make sure that we will get only the bottleneck machine. So in where clause we can see that the value of width of the sampling day have to be higher than the day before. So that means we are finding the increasing of width of the machines, and we order by descending. This means we are finding the highest width, the most problematic machines, and I got only top 20 rows of result. And here is the result. The top left one is the Oracle SQL result, and the bigger one is the result of Impala. And you can see that the results are the same, but the difference is here. To join 5 subqueries in using Oracle SQL, it took around 50 seconds, but in Impala it took only 6.5 seconds, so it's 7 times faster with the same results. So we can conclude that Impala brings fast interactive query and near real-time analytics. In the future, in the real use, we could configure Impala to work with Edge-based, also the third-party products. And as we know that Oracle database is the basic database for every organization, so I think it may be better to connect Hive Metastore with Oracle database. Thank you very much for watching my presentation.